So we'll keep moving here. This will be Lecture 5. Page 1 of something. Lecture 4 went a little bit long on us, didn't it? I normally try to keep 4 to 5 part lecture, 15-ish minutes each. So I'd be very close to 75 minutes. I try to keep very close to one lecture being the equivalent of a 3-hour class meeting 2 days a week. Normally we get there. We went a little long on lecture 4, but that's okay because I look at my notes for lecture 5 and it's a bit short, at least what we're going to work through. So I think normally what I would do is move a couple of example problems from lecture 4 into lecture 5. But here we are. Yes, Izzy, we're recording. Let me put Izzy on my lap. Okay, you have to sit down. I'm busy. Sorry, I had to put Izzy on my lap. Lecture 5, what I'd like to do, since in lecture 4 we did 2D problems really well, let us work on 3D equilibrium. That's going to be our focus in lecture 5 here. Now, 3D problems work very much the same as 2D problems. What do I mean by that? Well, we're still doing this. Remember this? And so this is what we do all the time. What are you looking for? What's known about it? Organize that into information. What tools do you have? Do you have as many equations as you have unknowns? If you do, then just go solve. If not, go back. Now that you've got new things that are unknown that you identified, and you go back to step 1. Repeat until you come out with as many equations as you have unknowns. That's 3D problems. We did that with 2D problems. We're going to do the exact same thing with 3D problems. That is our roadmap, and that's the commonality of any problem that you're going to tackle in any engineering course. So 3D statics problems are no different. The real difference here, one, is that the geometry can be a little more complex. It doesn't have to be. And it's not so much complex, it's just tedious because there's more information. You have a third dimension you now have to define. The other thing is now you have one additional equilibrium equation per free body diagram. You have now the sum of forces in the z direction. And then when we get past chapter 4, when we start getting into chapter 5 and beyond, you'll find also we're going to have moment equations. And in a 3D problem, you have 3 moment equations per 3-dimensional free body diagram. So geometry gets a little more complex. You have a little more algebra involved. I try to keep, when I put a 3D problem on an exam, I try to keep it pretty straightforward because it's really easy to get those to where it's just tedious the amount of algebra that you have to do. And I do try to avoid that when I pick problems. That's just me. Okay, so what else do we need to know? Of course, we're going to use position vectors to describe tension in cables. All right, we've seen that, so if I've got some cable between points A and B, then I'm going to write a position vector R, A, B. That's where you've got bx minus ax plus by minus ay plus bz minus az. All right, so that gives you a vector that describes the direction from between these 2 points, as long as if you're talking about the tension going from A to B, so to speak. And what you can do then is you can say, well, the tension vector AB is going to equal the magnitude of that tension times a unit vector in the direction of AB. And you would write the unit vector in this form, where I would take this position vector like this right here, RAB, and divide it by its magnitude. That's how you would construct a unit vector. Unit vector being a vector that has a magnitude of 1. So if I take a vector divided by its own magnitude, well, the magnitude, this is magnitude times direction, divided by its own magnitude. So magnitude over magnitude gives me 1, and it preserves the direction. So I get a vector with a magnitude of 1 in the direction from A to B, multiply by now a new magnitude being the tension in the cable, and that gives me the tension vector in the cable, just for example. All right, I'm right at the point of starting a 3D example. I think I'm just going to stop this video here and call that good, and that way we'll just start brand new on an example video.